Today we are going to look at the crankshaft, and previously I think taken a look at a connecting rod, a piston, and we're going to design and add a crankshaft. By next week we are going to put everything together in an assembly and try and animate the engine in motion. So the important thing is to take a look at the crankshaft, which is going to be driven by the piston. And the big end, this big end here, is going to be inside the crankshaft. So what is important is that this end, so you have to take a note of the diameter of this cylindrical surface here. And then you also need to know the width of this cylindrical surface here. So once you know those two, you can extend the crankshaft to fit that. The other things, the other end will be inside the piston. So the crankshaft is to be driven by the motions in the piston, transmitted by the connecting rod. In a normal engine, there will be a few connecting rods. The crankshaft will be driven by the piston, and it is the crankshaft that actually puts the vehicle in motion. So that crankshaft will be connected to the gear system, and it will now transmit motion to the wheels, and that's how a vehicle will move. So what we're having here is that the crankshaft is going to be taking this big end of the connecting rod. So this diameter here is the important diameter, and the thickness of this cylinder is also another important thing that must correspond to the things on the crankshaft. So in a normal engine, there will be a few connecting rods and pistons. All will drive a single shaft. We will create this in sections, beginning with a sketch that will make the holding cylinder conform to the big end of the connecting rod. This with the appropriate tolerance will be 60 millimeters for the connecting rod we have created, this connecting rod we have created. I think it is a good idea to look at this thing in full view. See, this is actually the full arrangement for a 6-cylinder engine. You see 1, 2, 3, 4, 5, 6. You have 6 pistons here, 6 connecting rods, and this is the crankshaft arrangement here. So this is the crankshaft arrangement, and we have done this in the way that is corresponding to the firing order of a particular kind of engine. So this is a realistic description of what actually goes on. So what you need to notice are as follows. One, you'll see that this piston is slightly different in looks compared to the piston we did. You can see that this piston has a top end and a bottom end. Maybe I should just allow you to see just the piston. Let me just see whether we can make that. Let me remove the end. Let me remove the end. Remove the, no, we'll take the connecting rod, we'll take the piston, we'll take the piece, remove the, let us, all that. Okay, let us remove the crankshaft. Okay, so if you look at this crankshaft here, let me remove some other crankshafts. Try to put this crankshaft here. Okay. So you can see how the piston, okay, let me even remove some of the pistons so that you can see the thing in full. So you can see the way this looks. It looks slightly different from what we had before, because here now you have this, there's a slit here cutting this into two, and you can see that there is an end here where you can attach the bottom part to the top part and use a bolt to bolt them together here. That wasn't in the piston we did. We don't have that. This is easily done. All you need to do is to take a plane here and create. You can create a sketch here and extrude it, and then after you have extruded it, you can cut it and create two components up and down, so that otherwise there will be no way of putting this but inside the crankshaft. So that is the only difference between this and what we did before. As for the top end, we didn't do it that way because we can just put it inside the piston and use a pin to hold it into the piston. But we cannot do that here because of the complicated nature of the crankshaft. And it is okay. Here now you can see that a single crankshaft is just a repeating, the crankshaft itself is just a repeating pattern of these two supports with this end. And once you just replicate that in a pattern, we have all of that. All that happens in the other ones is that they are just rotated. Apart from replication, then we rotated some individual ones. We will show how that is done. If you have watched the video I directed you to on the web, you should have seen how all these things work together in a particular way. But I deliberately am not using some of the methods of drawing that I have in that video, in order to show you that there is just not one way of doing anything. In Fusion 360, you can, the fact that somebody does one drawing one way doesn't mean that you are obliged to do it that way, because the software pretty allows you to do things in multiplicity of different ways as you choose. So this is an example of a system that is much more elaborate than that we get at the end. But no matter how elaborate these things are, they are just made up of a few. They're just made up of a few ideas, and then replications and assembly is what now makes everything, as you can see here. So we can go and create something like this. This can be created, and I think today I'm going to just do this on the Fusion 360 directly so that you can see how we can do this and get an example of the crankshaft section. So let us go and start. Let us go to the thing and start straight. See. Okay, so let's see. This is Fusion 360. Let's just start a new drawing. With a new drawing, you can say create a sketch. I always like to create my sketch on one of the vertical planes. Okay, create a sketch. You can start here with a circle 60. And then you can repeat that circle and do another circle, say 70. Easy. You can move this. You can move this up. And one thing you might want to do is to create a vertical line here. You create this vertical line. Create a vertical line, and you will see that it is vertical because of this vertical constraint is there. If you don't see that vertical constraint, you can apply it. And let me do that again. Control Z removes that. If you want to create a vertical line, to be sure you are doing it accurately, deliberately make sure the line is not vertical. So this is a line. Okay. And now what you do is that you just apply a constraint on it. There is a horizontal vertical constraint. If you apply it to it, that is now a clearly vertical line. So that line is vertical from the origin. If you want that line to be longer than that, there are several things you can do. You can take, if you want you want it to get that far, you can now say, okay, this line, I want this line to be extended. So you can use the extend modification on that, extend. You choose again, extend, you choose it again, extend. So that line has been extended. So that line, oh no, it's still not extended. No, I want it extend. Okay, so, and then I can trim that that thing that I had there. So you can see this line is a vertical line that goes all through. So I can choose that line and turn it to a construction line. Oh, no, undo. I want to undo the trim. So I can turn that line to a construction line by choosing it and pressing X. So that whole line is now a construction line. Similarly, I can take a horizontal line here. I can put a horizontal line here. So let us say that I put that horizontal line around 100. Okay. I wonder whether that is long enough. I want that line to be much longer than that. So let us just put it on one side. We don't need more than one side of it. So I want to draw another circle centered here. The circle centered here. Create circle, center circle. I want that circle centered here, and I want it to be about 60 still. $60. It looks smaller than this other one. I'm just trying to be sure. Let's see the 60 diameter here. This one is 80. No. I want a 60 in the center too. Okay, I want to remove this 80 that is out there. Okay, so that's better. Okay, so I have that. Now, what I want to do now is to draw a line that is tangent to this. I want a line tangent there. Now, so I want this to be tangential to this. So I'm going to use the constraint, the tangent constraint, this. So it has been drawn tangential to that. I don't know why it moved. I don't want it to move. So let me remove that. Sorry, I want to start these things from scratch. I'm not happy with what's going on here. Start again. I draw a circle centered at the origin 60. So it's black. Good. I repeat that circle here again. I want 70. Then I have a line. I can draw a line from somewhere far in front here down here. I want that line is vertical already, and it passes through the origin. So since it passes through the origin, if it did not, I can tell it to pass through the origin by a constraint. I can say that the constraint I want is that this line and this point and this point and this point, they all collinear. So I can say collinear constraint, collinear constraint, okay, collinear. I want this and this and this to be collinear. I'm not having, that's not working. So collinear, this and this. Okay. Oh, if that is not working, I don't know why, but there's another way I can get that to happen. What I will do is that I will make sure that the distance between, let's see, I can make the distance here 0, but that looks a little bit funny to do so. Let me remove that line. I want to make this collinear constraint, collinear. constraint collinear. It was not. Not successful again. So let's see. Take this line. Okay, let me take a line from here. Then I want to make this vertical. Constraint it to be vertical. Okay, so that is black now. Then I can extend this. I can extend this to a point far down here. So I choose modify extend. Okay. So this line is extended and I want to turn this to a construction line, X. Okay, so we're back again. Now, I want to take another circle here. I want somewhere up here, and I want it to be 60, center circle. Okay. And I want this thing, I want to draw a line from here, tangent to this. So I take something from this point. And I now want this. Well, it's moving, but I can make this fixed if I want by just taking the distance. I can choose the distance between here and here. So if let us say I want this distance to be 20, so I can just use a dimension, sketch dimension to say this right now is 24. If I say it's 20, so that gives it a specific distance, so it cannot move from there. So I have everything I want. The other thing I want to do is to select this angle. So I can create the specification of that angle by dimensioning it. So this angle, I want that angle to be 70 degrees. Okay. I can move this one still further up. I'm not happy with the distance between these two. I can increase that several ways. I can do that by making this 30. Okay, if that is good, and I can extend this line to join the center here by modifying, choose this line and then choose extend, and I extend it to this point. Okay, so I can now do some trimming. Trim this, trim this, trim this, trim this, trim this, trim this, trim this. Okay, so from here, I'm able to come here now and do a mirror. I can do a mirror of this path to the other side. Okay, before I do that, I want to fillet. I can fillet this place. And this, if I'm happy with that, it's giving me fillet radius of 20. You can take that. So we can now do a mirror. So create a mirror. The object, it says select object, so 1, 2, 3, 4. And then select the mirror line. So this is the mirror line. If it's okay. So the fact that it paints it light blue shows that this is already, it has already done the mirror here. So the fact that it paints this blue so that we can extrude this. So if you are happy with this, we can end this sketch and then we can go home and see it in 3D. So this is a sketch. Now what we are going to do, what we're going to do, we're going to create something that looks like one of these sections of the crankshaft. To create something like one of the sections of this crankshaft, this is what we're going to, how we're going to proceed. We can now start doing some extrusions. We can extrude this outer profile and then create extrude. We are going to create extrude. We have selected this whole thing. And it's asking, where are we starting the extrusion from? Is it from the profile plane or offset? We are starting it from an offset plane. And we are offsetting it by, say, 12. We are offset by 12. We are offsetting by 12. And we are making it an extrusion of 10 after we have offset by 12. Is that going to be big enough? Then that means that in between that will be 20. That's probably okay. So, and we're creating a new body. So that is the extrusion. You can see that if you go back to the picture, you will see that we have something that looks like this. It's not exactly like this. If you want it to be exactly like this, you can do a little bit more work and you can get it to be exactly like this. So this is something like that. One thing you notice is that after you have created that thing, the sketch goes off. But we are not finished. We are not done with that sketch yet. So we can go back and turn that sketch back on. So you go to the sketches here and you pick it and you turn the sketch on so you can see the sketch reappears. What I want to do next is to do an extrusion. Let me edit this one to see how much, what did I do for that extrusion. I did feature. I moved it 12 millimeters away. So I want to cancel that. I want to do another extrusion. So I want to extrude from this annulus here. So create extrusion. And we're creating the extrusion there. And that extrusion would now start at an offset of 10. And it will be going through a distance of 2. And it will join the original thing. So you can see this extrusion now is an offset of 10 and it has joined. I want to do a third extrusion. Create extrusion, create extrude, and it is now coming from the inner one. I want it to start from an offset plane of 12, and I want it to go a distance of minus 12. So it goes right to the coordinate plane. And I say, okay. So let us take a look. Let me turn off the sketch now and see what we have created. So what I'm going to do now is to mirror this to get the leg of the crankshaft. So if I mirror this whole thing, I just say create mirror, create a mirror. This is a 3-dimensional mirror, unlike the 2-dimensional mirror that you needed a line. When you create a mirror like this, you will need a plane. So create mirror, and you are creating mirror of bodies. So this is everything here is a single body. And then it says mirror plane. You now want to select the mirror plane. So to select the mirror plane, you can go to the browser and make sure that the origin is clear. So you can see what plane. So this is the plane of the mirror that I want. That is the XZ plane. So if I'm happy with that, I click OK. So now what do you have? What you have now is this. you can see that inside there we have a place to hold the big end of the crack, or big end of the connecting rod. If this distance is too small, we can go back and do an editing. So if I edit this feature, maybe instead of making this offset 12, I make the offset 15. I make the offset 15 and I make the distance 13. Okay. And then the second extrusion, I can go again and do the second extrusion, edit feature. That offset will now be 13. And the extruded distance will be 2 to join. And then let's see whether that has, then that is it. The third one. The third one is to create edit feature. The offset now is 15. And the distance is minus 15. Minus 15. So when we do that, you see again the problem we had before has gone. So this may be better than before. So this is the space for our connecting rod now. If you think this thickness here is too much, we can go back to the editing. We can go back to the sketch and edit the sketch. If I edit this sketch and I change this to 65 instead of 70, and I agree with that, so you can see everything again has now become thinner. This thickness has become thinner. You can make it smaller if you want, as you choose. So that is this. So what do we do next? The next thing to do is to create another circle outside here. So we can create a new sketch. Create a sketch. So we are creating a sketch on this surface. So when you create a sketch on this surface, to where the center of this circle will be half of the motion that you want in the piston. Half of the up and down motion that you want the piston to make. So we can come here and say, maybe we put it at this point, the center circle. And then this one now can be, maybe let us make it 80. And finish sketch. So we can come here now and create an extrude. Now, I want to create an extrude of this one. Go there. So create extrude. Okay, finish stage. Create extrude. The extrude should start from the profile plane this time. Okay. So and we can join it let the distance traveled there be, say, 25. Join. Okay. So here is the section, the repeating, this is the repeating section of the crankshaft. So let us go and look at the original drawing, and then you see. The only thing is that we did a little bit more. We did a little bit of design at the end here. So at the end that touches the body is a bit thicker, and at the other end is another thickness. You can add all those things to it very easily. One way to add it at the end. One way to add it at the end, you can do that by creating another circle here. Go to the second sketch, edit this sketch. You can create another circle and say create center circle. And then since the first circle is 80, let this other circle be 83. Finish sketch. Okay. So we can make that second sketch visible. So we can now do some extrusion, create extrude. Okay, that extrusion. Let us say we do an extrusion of 2 millimeters for the profile plane out. So once selected, profile plane, one side, a distance of 2, or let us say 4, because I can't see it, 4, and join it. We can do another one. Can create another extrude. Now we can choose this and this, and we can start at an offset plane of offset plane of 20. And then make it a distance of 4, and it is again a join. So if you look again, you will see that this is looking like you want it to look. So this one is, I started too early, so let me move it out. So let me edit that feature. Edit the feature. We should do an offset of 25. Okay, so it's better now. So set it at 25, and then you can see this. So this. So of course, we can do a pattern replication of this. Let us say we want 3 copies of this. So I can first of all make a component out of it. It is good to make a component out of it. Create component from bodies. Let us see. Component from bodies. Let me just see whether I can do that. Component from bodies. Where are the bodies? Yes, create component from bodies, and that component is crank section. To name the body, I want to name the component. To name the component, I mark it here. Okay, so sec. Okay. So that is that. So this whole thing now is a whole component. So we can now replicate this. So let us say I want to make 2 copies of this. So I can create a pattern replication, rectangular pattern, and the type is components, and then select a component. This component is selected. The direction is the, let's see, this X direction, Y direction. I want it to go the Y direction. Let us say I want 3. So there are 3 of them, and the distance, if I'm correct, should be 170. Now, this is not how any vehicle will look like, because this have to be oriented at angles to one another. So what we are going to do now is that we are going to do a rotation. So if this is okay, we are going to do a rotation of some of this. So we have crank 1, crank 2. So let us see. We can rotate. We can rotate about an axis. Let me try and rotate. Modify. Move, copy. I want to take one of this, and it's a rotation that I want. And it is a component I want to rotate. And the axis of rotation is the axis of rotation is the, let's see, to choose an axis of rotation. The axis of rotation is the axis around which this circle turns. So let's see, how do I get that? Select axis. So that is the axis of rotation. And then the degree of rotation, let us say I put 60 degrees. Component selection. I'm not able to select the component. Let me start again. Want to rotate that. Select component, rotate. This rotation. Then select the axis of rotation. Okay. And now rotate it. If you rotate it, say, let us rotate that one. If we are to divide 360 by 3, so 120 or 240. 240. Okay. So I want to do another one. Move, copy. I want to select the component. This component. And then I want to rotate it. The axis of rotation again is the axis that is center, the axis of this one. And then the angle I want to use for that one is 120. No. So I want again to create love copy, modify. Select this component. I want to take the axis of rotation to go back this way. To go minus 60. Let's see. Okay, so we have can go home now and see what we have done. So these are, so you can continue depending on how many sections you have and what angles you want them to be rotated to. So you can have a connecting rod that is where the positions are rotated at rotated angles to one another. So this is what you do to get something like this. So the other thing that is here that you might want to look at is to take the connecting rod and do a do a screw hole on both sides of the connecting rod. And after you have done the screw hole and cut it into, just do a slit of it so that there are two components. So the connecting rod now will consist of two components. Well, you can continue like this and get, so what I want you to do is to do the individual, just do the individual connecting rods, do the individual sections of the crankshaft and be able to rotate them at will. But don't do the rotation yet, because it is usually much more efficient to do everything when you have gotten a complete assembly. Because if you do a complete assembly, all the rotation will take place, including the position of the piston, so of the connecting rod. So it's not, what I have done here is I don't advise you to do it. Don't do. I just want to show you that you can put these things at angles to each other, but you are not. What you are going to do, make sure you do a single section of the connecting rod, a complete connecting rod, complete section of the crankshaft, complete piston, and while everything is complete, then we are going to do the rotation together. So when we do the rotation together, we are going to impose the motions. When we impose the motions, what will happen is that when we impose the motions, what will happen is that we will constrain the piston to only be able to move vertically. And we constrain this end here to only be able to move inside that place. So that when we rotate, as we are rotating it, this one will only be constrained to move vertically, and we will not need to do any computation, and Fusion 360 will do all the computation, and then it will do the animation by itself. So in order to achieve that, just do one section complete. And then we are going to replicate not just a single section of the crankshaft, but a single engine. We are going to replicate it in all these other places and do the correct rotations to make the motion possible. That we will do in the assembly of next week. So what I want you to do as homework now is to go. Sorry, let me just turn off my phone. Okay, so let's see whether there are any questions on what we have done. So let me go back to see whether there's anybody chatting a question. Is this clear, or is there any part of it that is not clear that you want further explanation on? Okay, it's clear? Okay, good. So if it's clear, so what I want you to do, go and see how far you can go in creating your own piston, turning the connecting rod into a double component. There's one component which is the bottom of the connecting rod, another one is the top of the connecting rod. We are going to assemble them together, and then we're going to put them in make a single engine. When you make a single engine, then we can replicate the engines. Rather than replicating the connecting rod, we replicate the full engine and rotate accordingly. So when we replicate the engine and rotate accordingly, if you want to do it on your own, go and look at the assembly, go and look at my assembly in the video that I put online. So you will know how to do that once you do. But those who cannot still do it by the new week, we will come and finish that up in class. Well, I'm not going to go beyond that today. So what I want to do, I want to give you as a challenge to go and get an engine like this 6-cylinder engine. And you can watch the video that I've given you and see whether you can do the assembly. If you have difficulties, then you discuss the difficulties either online or with me next week. If there are no questions, I will release you, and this will be the end of our class today.